Hello everybody, I'm Nick, and in this video I want to talk about 8 await async mistakes that you should avoid in .NET and .NET Core in general. Now, I want to talk about what await async is. There are many videos that are talking about the same subject and they cover what is in depth. My favorite one personally is one from Raw Coding. I'm going to leave a link in the description down below, but you can watch that if you want to understand how await async works and what it is. In this video, we're going to talk about examples that you might see in your everyday code and talk about what you should and shouldn't do. And this is based off a repo from David Fowler, who is a partner software architect at Microsoft. And he's the guy who made Sigler R. I think he also made Kudu and NuGet. So he's a guy who really knows this stuff. And I'm going to make a video form of that page. And I'm going to leave a link in the description of that page as well if you want to read that. It goes through some extra stuff while I compiled what I think are the functional things that you're going to see on a day-to-day basis. If you're going to go to a specific topic, you can use the timestamps in the description down below. So without any further ado, let's go straight to the video. This video is part of my general ASP.NET Core series, so if you don't want to miss any episodes, please subscribe and ring the notification bell to get notified when I upload a new video. So what I have here is a solution with a bunch of projects, and each project has one of the use cases I want to show. So we're going to start with the first one, which is called once async, always async. What this means is that once your project has an async call and you're awaiting something, you should await all the way to that call. It's usually going to end up in a network call or an IO call of some sort, like a database call or a WebSocket or something. But once you have that, and you can await it all the way. So in this example, I have a void main method that will call a repository that has an async method. And when you call that async method, it gives you back a result. Now here I'm synchronizing the call because it might not go through a network call or something. But really, there is a way that I can actually await this all the way. And it is to change my async main to an async task. Now, this could be an endpoint in a controller or an event that happened in WPF application or that sort of thing. But there is pretty much always a way that you can start this async flow from top to bottom. So in this scenario, we just properly await and we change this to async task. If it was a controller, it would be an iAsync result, and you'd want to make that an async task of iAsync result. Now, the next one I want to talk about, and I have covered this in a different video as well, is that async void is bad. So what I have here is just a random repository that returns some value. It doesn't have any purpose here, and in reality, this isn't really doing anything other than just returning 1. But what I want to show you is in the controller, in this project, what I have, this is the dummy controller that comes out of the box with .NET Core. I have an async void of some background thing that I want to run. And if I actually run this project, let me show you how this behaves. I'm going to call the endpoint in Postman. And as you can see, I get a response. And after a while, the number is 1. This happened with a 2 or 5 seconds delay. I think it's 2 seconds. Yeah. So we waited for 2 seconds here to do some background task. The task here is just to print something in the console. In your case, might be send an email, send a notification, that sort of thing. Now, the thing is, you shouldn't really be using async void for this thing. And the reason for that is actually quite interesting. If for some reason this thing throws an exception, and let's say that the mail failed, and there's an exception here, and let me rerun this real quick. I want you to see what will happen. So running the endpoint again, I got my response. But I got a fatal exception. As you can see, my compiler broke. And if I run this through, the process is killed. The thing is not running anymore. I didn't stop it, but an exception in an async void that's running as a background thing will actually cause the whole process to crash. You might not have seen this, or your application might have crashed and you don't know why it has happened, but you really shouldn't be doing this. There is a way around this. And the way around it is to use Task.Run, which in this code, I'm going to change this again to an async task here. And what I can do is I can simply say, let me just copy this, Task.Run, and I'm going to paste the method name. And now that's it. So let me just put back the exception here. So throw new, Theo is not a word, throw new exception and some sort of text. And if I debug this and run it again, you will see that now the application will not throw, but it will also won't die. And the reason why it won't throw is because it is in a fire and forget Task.Run. There is a way to change this so it throws an unobserved task exception, but I feel like this is not part of this video, so I'm gonna leave this outside. But you could normally, if you wanna handle it yourself, if you expect something to happen here, you could very much do this. You could wrap it in a try catch, and if you restart the application and you hit the endpoint again, you will see it properly thrown here now. As you can see, it is. So Task.Run is its own beast, and we're gonna cover a few of the use cases in the next project, but this is all about async voids and how you should not be using them. So change it to an async task. So the third one is called prefer from result over run for pre-computed stuff. So what I have here is some service that is getting some value, it's doing some stuff in there, and it's returning a new number. And if I take a look in that method, you'll see that all it's really doing is it's multiplying it by 2. But I've wrapped that to an Task.Run because there might be some async flow that I need to follow. So I have effectively what is a trivial thing that I want to run in an async fashion. Now, the problem with that is Task.Run will waste a thread pool thread and will put it back into the pool without really doing anything with it. So you're wasting resources. What you want to do instead in that scenario is you want to do Task.FromResult. And you don't need this. You can simply do that. And this won't actually waste any threads from the thread pool. It's way more efficient. And you could actually take this a step further, because in C# 7.3, I think, I could be wrong on this, value task was added. And value task is a bit of a different thing than simple task. And the reason why we're going to use value task is because value task is a struct and it won't actually allocate any object on the managed heap. And in order for that to actually be a thing, I need to copy that. I need to take this and I'm just going to put it here and return the result. So this is also more memory efficient other than just more resources efficient in terms of thread pool. So this is a better way to do it. Now, however, there is some fine print in using value task. I also won't cover this on this video. I'm going to link the page for value task in the description down below to read more about it. But just know that for trivial pre-computed stuff, it's better than using Task.Run. The fourth one is called sync over async. I have a program.cs here, and what I'm doing is, because I have a void method and I have an async call, I'm doing a .result to synchronize this call. The problem with this, and you might hear this a lot, is that it can cause deadlocks. However, .NET Core fixes this, because .NET Core doesn't actually have a synchronization context, which is what was causing that to begin with. So it will work. The problem with it isn't just that it's going to cause deadlock. And by the way, it's not just .result, it's also .wait. This can also do the same thing. So it's not the synchronization context and the deadlock that is bad. It's that it will result in the use of 2 threads instead of 1 to compute synchronous operations. So again, potential thread pool starvation and wasting resources. So if you have something like this, you really wanna await it. Some people might say, what happens if you cannot await something? Well, realistically, in any .NET scenario, modern .NET scenario, there is no way that you cannot await a call. Pretty much everywhere, everything can start from an async scenario, an async task, and you can keep awaiting them all the way down to the final call. There might be a use case that you are thinking right now and saying, hey, what's happening? And that's the constructor, and we're gonna cover that in one of the next projects. So the next one is prefer await over ContinueWith. I have a program.cs here which has an async call, and then I'm doing ContinueWith, I'm getting the task, I'm getting the result, and I'm adding 2 to the number. So I'm using ContinueWith here to sort of chain something with the result of this on something else. And I've seen this quite a lot, and some people also use it for fire and forget stuff. I can understand that, but the thing is, never use it like this. And to be honest, I think David Fowler would argue that you should never use it in general, but I digress. What you want to do instead is you don't want to do this. You want to get the final number, let's say, which is the number you get from an async call plus 2. You might be thinking, hey, nobody does that. Well, actually, people do that. So this is why I included it. And you might have a very niche case for ContinueWith, but I've never personally seen it, and I've seen a lot of code be used in a way that using await async doesn't make more sense. There's also some fine print about capturing the correct synchronization context, but like we said, .NET Core works differently, so it doesn't really affect that. But if you use ContinueWith, I think your code also looks cleaner because you don't have this nesting of chaining the calls. It looks like a Fluent API, but it doesn't really look like it when you read the code from top to bottom. So yeah, don't really use ContinueWith if you can. And the next one is called always pass cancellation token. Now, I cannot tell you how many times I've seen this and people question its usage and its functionality and why you need it, but it's actually great. So in case you didn't know that, pretty much every controller method, actually not pretty much, every controller method can also have a cancellation token parameter. And this is automatically populated from .NET Core, and you can use that and you can pass it down to effectively what will be an IO call, potentially a network call to an HTTP client, or it could be a database call, a SQL call, any sort of IO call. I think even file IO can actually use it. And the reason why it's used is because .NET Core will notify you when the request is cancelled, and a request can be cancelled. And let me show you that. I mean, I'll show you this when I run this. But what I have here is I'm passing down the cancellation token, and even though I don't have an IO call, I have a delay of 5 seconds with the cancellation token. And then I have an asynchronous Task.Run, which I'm awaiting. And let me show you what happens if I cancel without the cancellation token. So if I don't use it, right? So let's do this. So we don't use it at all. So let's fire the request, and I'm gonna cancel it. I cancel the request. And as you will see now, wait for 5 seconds, the thing after these 5 seconds delay still happened. I wasted my resources. I called the database, even though the user said, I don't want to see this data. And you can have this scenario with people constantly refreshing a page, or just pressing the X button on the browser, or just people leaving the website that started, a bunch of API calls as they entered. So all that can actually be caught, and the cancellation token will be triggered. And let me just put it back, stop this, and rerun it, and show you what happens now. So if I do that, and I run the request, and I cancel it, now I instantly get this exception. But as you can see, no message saying wait the 5 seconds, no nothing. This threw a task cancelled exception, and it says a task was cancelled, which is what I'm expecting when I'm canceling a cancellation token in this context. If you were using a true IO call that goes to a database, then the library would actually be handling this and canceling it silently. To simulate that, what I can do is I can run this, and I can get the name of the exception here, so task cancel exception, and say that I don't really want to act on it. Let's just silently cancel it, and let's return an empty enumerable context. So enumerable.empty of that type. You can handle this any way you want. It doesn't really matter. I just want to show you what happens when you actually cancel it and handle it gracefully. So I can go back here, I can press get, and if I let this run, it's going to wait 5 seconds and give me back the data. So let's see how the happy path is working. As you can see, wait 5 seconds, got the data back. If I start it and cancel it, I didn't get any data back, and it doesn't say wait for 5 seconds twice. So it's gracefully canceling the request without actually throwing any exceptions. It is throwing it, but it's catching it silently. So please pass the cancellation token all the way down. That's the whole point of this, because it will save resources. You won't need to waste time computing any maths or any model mapping or any IO calls after a cancelled request. Please, please, please use it. So the 7th one is called prefer async over task. So what do I mean by that? You might have seen this where there's some sort of IO call. Now imagine this is calling a database and it's not just getting one. And people have a task and they return a task without actually having the async and await here. Now, there is a valid case for it. I'm not saying you shouldn't definitely do it, but you should know exactly what's happening when you're using it. So when you're using await async, the asynchronous and synchronous exceptions are actually normalized to be asynchronous. The code is also easier to modify because you might be seeing this small thing here, but in a bigger method with more IO calls. Having these tasks floating around and just returning the task without actually awaiting them can be a bigger pain. Last but not least, exceptions thrown in here will be automatically wrapped in the returned task instead of surpassing the caller with an actual exception. So debugging is better, exceptions are also better, and the code is easier to modify. Also, imagine using the using keyword in here, it would be a mess. So there is that. Now, please note here that using task and async await and using the state machine that is built behind the scenes will always have some performance hit. The performance consideration should actually come into picture when you really need those million microseconds really, or even nanoseconds that you might be wasting building the state machine and going through the state machine. But again, this is a topic for a different time. I don't want to go that in depth and talk about exactly how the state machine works because this will be a long video. And last but not least, probably the most important one and the one that I've seen being done wrong everywhere pretty much is async in constructors. So as you can see, we have a connection factory which we're passing into some service and we're getting some service back. And this connection factory is creating some SQL Server connection, let's say. So in here, and you really don't need to know what's going on in that. So this service requires a my connection, can be a database connection, let's say. And what I'm doing here is because I need to create the connection to the database so I don't have latency in the beginning, what I'm doing is I'm doing a .result to start the connection. Now, this will synchronize the call, which is a really bad practice, as we mentioned already. We don't really want to do that. It has the same thread starvation and deadlock scenarios as we mentioned before. And this could be a singleton, so it's no biggie. But if this was a scoped or a transient dependency, and this was happening on every call, you could really go to a thread starvation scenario. So what you want to do instead is you want to change it a little bit and play with the factory pattern. So you want to make this private and you want to inject the actual connection instead of the factory here. So normal stuff, my connection equals my connection. And by making this private, as you can see in my program.cs, I can no longer do a new service and pass the factory. And that's not because the factory is not what it's requiring. It's because the constructor is not accessible, so it won't allow me to do that. What you want to do instead is you want to say public async or static async task, and now we can have that, and we're gonna return itself, so some service, and we're gonna say create async, and now we have the dependency that we had before, which is the connection factory. Yes, connection factory. Let's just call it factory. And now in here, I can actually have all the async I want. So return new some service that has the factory.connect async, and we're gonna await it. So properly awaiting the connection opening call. and go back to the program now. I'm gonna change this to an async task because I can. And I'm gonna say some service.create async, and I'm gonna pass my factory. And now my whole flow is async, and I can properly await this. So that's how you deal with asynchrony in the constructor. Now, in general, if you need to have logic in the constructor or async calls, you might be doing something wrong, but this database opening scenario is something I can totally get behind. Some people do this by having normal service registration and then calling open async or create async in their DI just to kickstart it. But I prefer this method. It's more clear. You know how the thing is built, and you can pretty much do anything. Dependency injection will become different because you will need to register this method in your DI container instead of what you would do normally, which is the constructor, but it still works. That's all I had for you for this video. Thank you very much for watching. Special thanks to my GitHub sponsors for making these videos possible. If you want to support me as well, you're going to find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.